Hey class, welcome to our 5.2 video on gravitational potential energy. So today we're going to talk about energy in a system. So an object or multiple objects together, how do we give them types of energy? And this is all building towards something called conservation of energy, but we got to learn about the individual energies before we can then move towards conservation. So today we're going to talk about something called gravitational potential energy, or GPE, which is just kind of a shortened way because writing out gravitational potential energy a ton, it's a hassle. So when it comes to gravitational potential energy, first we have to ask ourselves, okay, what does potential energy mean? What does it have the potential to do? And in our class, it has the potential to start moving. It has the potential to change motion. Primarily maybe changing direction, changing its velocity. Again, some sort of acceleration is going to be happening if I allow the potential energy to transfer. Now, we can see via gravity, this is gravity doing that, would be the one that's changing its motion of an object falling. Well, GPE specifically is the energy associated with height. And so the only way I can really change gravitational potential energy is by changing the height of an object. So we end up with this equation where we have the GPE, the gravitational potential energy. I'm going to write it out in word form first, is the mass of an object times the acceleration due to gravity times the height of the object. So written out in variable form, which is what we usually see, we have U, which is the representation of potential with a subscript G, so we know it's gravitational potential energy. So you go to the mass of an object, M, times G, times H. And you can see above, we have those corresponding variables up above. Now, the unit here, if we were to do a little bit of unit analysis, which we've done in the past, I would have kilograms times meters per second squared times meters, which gives me a unit of kilogram meters squared per second squared, which converts into joules. So we have the same energy for work as I do for energy. That's why this unit's kind of tied together, because work and energy go hand in hand with one another. So let's get a little bit of practice here. We're going to look at two different sets of problems where we're just going to kind of be rearranging this equation about. So we're going to be raising objects up. We're going to be allowing them to fall, maybe see how high they are based on their energy. So I'm going to leave that equation up at the top for us. And let's look at example 1 here. Example 1 is going to be a picture. So I'm going to have an object up here, a box of some kind. That box is going to have a mass of 10 kilograms. And it's going to be sitting on a cliff that has a height equal to, H is going to equal 200 meters. Okay, so that object's going to be pretty high up in the air. And so we're going to release it. And before, though, I want to know, our goal is to find the potential energy. So I need to find UG. Well, let's make sure we do our guess method here. So I know I have a mass of 10 kilograms. I have a height equal to 200 meters, and I'm looking for gravitational potential energy. There's my givens and my unknown. Now we'd pull out our equation. Well, when I have these, let's go to our solve step here. And I have UG is equal to mgh, which our mass was 10. G is equal to 10 in problems, so we know that, times 200, which gives me 20,000 joules of potential energy. So that, again, it's pretty straightforward. What's nice at this point in the semester is we're used to using equations. So doing something like this isn't new, it's just a new equation. So we just have to make sure that we're identifying variables and plugging them in where they need to go. But let's look at one other example. So we're going to go down. How high is a 35 kilogram object if it has 1,000 joules of GPE? So go ahead and try and draw yourself a picture of what might be going on. I'll draw one to the side as well. A lot of these are just going to look like little cliffs. So I'll have a 35 kilogram object. I don't know the height, but I do know that its UG is equal to 1,000 joules. So then I'm going to go to my given step. What all do I know? Well, I know mass, 35 kilograms. I know UG is 1,000 joules, and I don't know my height. So I'm going to go to the equation step. And as you know, this is a time where you can pause the video, solve it yourself, and then come back, see if you can get it. But I'm going to have my equation, UG to mgh, and I'm solving for h. So I'm going to divide both sides by mass and acceleration due to gravity. So I end up with height is equal to gravitational potential energy divided by mass times the acceleration due to gravity. And at this point, it's just plug and chug, right? 1,000 divided by 35 divided by 10, which is going to get you, I'm going to use my calculator here, get you 2.86 meters off the ground. So there is your final answer. Now, what you're going to do is you're going to go take this, you're going to go to apply it to our worksheet 5.2, which is all about gravitational potential energy. It's a pretty quick worksheet because honestly, this stuff is, we've been doing this. We can understand as long as we have the concept of what it is, how high an object is, tells me its potential energy, then I'll be able to work through any of these problems. So good luck. Come ask me questions if you have them. And guys, don't forget to be awesome.